Hi, pre-calculus friends. Here we are in section 3.3. We're going to be talking about graphs of nonlinear inequalities. And this time we can get straight to the examples because we don't have any vocabulary today. All right, so the first thing that we're going to do, example 1 asks us to determine whether these points, 3, -4, 4, 7, 1, 1, and -1, 6, are solutions for this particular inequality. And so what we're going to do is actually just take each point, plug it into the inequality, and see if it satisfies the situation. And so I tried to color code it so that we could have an easier time following the information. And I'll take the time to do the first one, and the rest I'll just show you the work for. So if I plug in 3 for x and -4 for y, I'm checking this out here. So I'm going to put my positive 3 here, my bad, -2 quantity squared. So I'm just substituting in the point and seeing if it works. Seeing if this is true, 3 minus 2 is 1, 1 squared is 1. So I end up with 1 minus 3. So I have -4 is less than or equal to 1 minus 3, which is -2. And since this works, this point is a part of the situation because is a part of the solution rather. So -4 is less than or equal to -2. And so I'm cool. I'm going to try this next one that's in purple. And I'm just going to do the same thing, plugging in 1, 1. And keep it going. And I think you guys know how to do this, so I don't think I have to do all of them. So 1 minus 2 is going to be a -1. -1 squared is 1 minus 3. 1 minus 3. So is 1 less than or equal to -2? The answer to that is no. Since 1 is not less than that, this is not a solution and it doesn't work. See how it works out? Okay, I'm going to do the other couple problems for you guys, and we'll talk about it in a minute. So as you guys can see, we did the first two, and then doing this next one, this one in blue, the 0.47 does not work, and the -1,6 does work. So this is how we test to see if solutions to inequalities work out when we're given points. So for this next example, we are asked to graph y is greater than or equal to the quantity of x minus 4 cubed minus 2. And so you can see this is an inequality. The first thing you want to do is consider the graph of y equals x minus 4 to the third power minus 2. You know that this is a polynomial, and in a sense we can kind of consider the parent graph to this. And the parent graph, hopefully you can think about this, will be y equals x cubed, and you can see that there's a horizontal shift to the right 4 and then a vertical shift down 2. And so I can kind of start off. This graph would look something like this. That would be the parent graph, like that. And let me make this a little bit lighter. Let's see if I can do it like that. Boom. Okay, so make that a little bit lighter so we're not confused by it. And so what we're going to do is now graph the actual function. So we're graphing y equals this, but remember we're doing an inequality. So the first thing we want to know is, should this graph be a solid or a dotted graph? This indicates, because y is greater than or equal to, that the equation should be drawn in full color or solidly. And so the first thing I'm going to do is now take this little piece here of the parent graph, and I'm going to shift it over 1, 2, 3, 4 and down to 1, 2, so that my vertex, in a way, or I'm going to call it a curving point or a turning point, is going to be right here. And when we graph this guy, it kind of goes out one, up one, does something like this, and then goes back one, down one, and it goes like this. See if I can do that. All right. So it's going to do something like that. All right. So that's the graph that we're dealing with, and I can even make it a little bit larger if we need to. So this is a part of the graph that I am graphing. So this is a part of the inequality. Now the next part is to figure out what side of the inequality that we want. This graph is going to cut the coordinate plane into two sections, two boundaries, if you will. And so those boundaries are what we're thinking about, which side works in terms of a solution. So what many teachers will tell you to do, and it makes perfect sense. I'm getting rid of that one. It was a little distracting. What many teachers will tell you to do is to choose a point, plug it into the inequality, see if it works. The point that people often choose is the origin. So if you can easily kind of do this in your head, you put 0 here, 0 here, and then you check it out as 0 greater than or equal to -4 to the third power. which is going to be negative 64 minus 2. Is 0 greater than or equal to negative 66? And the answer is yes. Therefore, this side where this value is what we want to shade in. And this side where that value is not what we want. That is very typical. Lots of teachers do it. If you can't do the origin, do another one. I'm going to tell you how I do it. And I've always done it this way, and I have not been proven wrong yet. So I'm going to share it with you. The way I look at this and the way I was taught, or at least the way I learned it, is that y is greater than, we want all y's greater than this function here. And y greater than or equal to would be above the function. It would be above. So if I imagine myself, I can't show you me holding a pen at this line, but or at this curve, if I imagine myself standing on this curve, where is above? I'd have to jump up. And so that's how I do it. I don't often plug in a point, but I think both are fine. It makes great sense to plug in a point and kind of think about it. So with that, let me go ahead and shade in. And so what you want to do at this point is just shade everything in on this side of the coordinate plane of the line, of not the line, but the curve. And so all of this is the solution. You guys with me? Hopefully that makes sense. So it doesn't look really pretty, but this is it. So this shaded region, this half of the coordinate plane, including the graph, is what my solution is. All right? So this next example, example 3, is asking us to graph an inequality that has an absolute value in it. And so what I want you to see is that this is like the parent graph situation. You remember y equals the absolute value of x is going to look like a v at the origin, and then we can start moving things around. Let's rearrange this inequality just to look a little bit like that situation. So what we'd have is a negative absolute value of x plus 2. Let me do that there, is plus 3. So now if we look at it like this, we can see the vertical shift, the horizontal shift, even a reflection in over the x-axis. So you see a couple things going on. So first of all, if we were to start off with the parent function, we'd have a v here. Then this plus 2 tells me that I'm shifting it 2 spaces to the left. Then this negative tells me that I'm flipping it upside down over the x-axis, and then the plus 3 says that I'm lifting it up 3. So I'm going to do all the things, okay? So let me see, maybe I should, I don't know, I just want to go over it. I feel like it's a valuable thing to go over. So if you're looking at this like we got it already, then just be patient with old people. All right, so the first graph, if we think about it, the graph would look like this. That's just the typical graph. Then if we were to think about what's happening here, we move it over 2 spaces, 1, 2 in the negative direction. So it's going to be like this and like that. So that's the first thing. The second thing is we can think about flipping it over. This is a reflection, flipping it over the x-axis. So it's actually down here now. And then finally, we're going to lift it up 3 points. 1, 2, 3. That's a vertical translation. And then so we end up with this graph here. And I'm going to erase all the other ones because they are no longer necessary. And so hopefully this is going to make sense. All right, so this is what we get. Just without plotting points, just kind of thinking it through. And now the question is, since we're graphing this inequality, and we first obviously graph the related equation, which we just did, which is y is equal to negative the absolute value of x plus 2 plus 3. After we do that, we have to determine if it should be solid or dotted. And hopefully you guys can tell already that it's dotted. So this is a dotted line that we're dealing with here, or dotted curve, a dotted absolute value curve that's going to do one of these numbers here. And I know I'm not doing an exact graph here, but I just want you guys to see how to do it. I expect your graphs to be better than what I'm doing here, but I want you to see the basic turns and twists that happen. Okay, so with that, now the question is where to shade. According to my method, I'd just be like, ooh, look, y is greater than means above. And I literally shade above. But let's go ahead and honor the textbook and what we are supposed to do. We choose a point, we test it, and we see what's going. So let's see, I clearly know that this point right here, which is, let's see, 0, 1, 2, 3, 4, 5, 0, 5. I'm going to test and see if 0, 5 satisfies the inequality. If it does, then I shade there. If it doesn't, then I'm going to shade in the opposite direction. And so When I plug a 0, 5 in here, I'm going to put 5 in here. Is that greater than 3 minus 0 plus 2? The absolute value of 0 plus 2 is 2. So this is basically, is 5 greater than 3 minus 2? And indeed it is. 5 is greater than 3 minus 2. 5 is greater than 1. Therefore, since that satisfies the inequality, I am now interested in shading everything above that line or above this particular shape, this V, upside down V, and this is the solution to this inequality, not including that line, even though I kind of did there with my erasing. So I'm with my shading. So I'm going to try to erase that part there. Is this making sense, guys? Let me know. Let me know. All right. So let's go ahead and look at another example. So there's a number of ways to solve, or a number of techniques that we use to solve inequalities when we're dealing with, polynomial expressions or polynomial inequalities. And in this case, we're going to be kind of straightforward. The first thing I would do in a situation like this with an absolute value, and every situation is different, but with the absolute value, I want to isolate that. So x minus 2, absolute value. I'm going to move this minus 5 over to the other side. So x minus 2, the absolute value of x minus 2 is less than 9. Now this requires that, because if I add 5 to both sides. So this requires that we kind of think it through. I have a number of techniques that I use for this. Some students kind of have a different way of approaching it. Here's how I do it. I tell kids, hey, write this number without the absolute value, put the same symbol on each side, boom, bap, put a positive 9 on one side and a negative 9 on the other, and we keep it moving. This is what I ask students to do. So at this point, now this is really we can see that this is kind of a conjunction. We've got two situations that we're dealing with in a way. X minus 2 has to be both greater than negative 9 and at the same time less than 9. And so what I'm going to do is solve. I'm going to isolate x by adding 2 to all parts. To isolate that, there we go. And then so we get a negative 7 is less than x, which is less than 11. And so this is my solution for this inequality. All right, this brings us to example 5 that is referring to like the beginning of the chapter where, they give us some really funky information. So let's go ahead and read. Pharmacology. Pharmacists label medication as to how much and how often it should be taken. Because oral medication requires time to take effect, the amount of medication in your body varies with time. Suppose the equation m of x is equal to the following. For all x values from 0 to 6, less than or equal to 6, models the number of milligrams of a certain pain reliever in the bloodstream x hours after taking 400 milligrams of it. The medicine is to be taken every 4 hours. At what time during the first 4-hour period is the level of pain reliever in the bloodstream above 300 milligrams. All right. So that's really the question that we're approaching here in example 5. So at what times during the first 4-hour period is the amount of pain reliever in the bloodstream above 300 milligrams? So the first thing we want to do is kind of figure out what this thing looks like. So we fortunately are not going to graph this by hand. All of our wonderful tips and tricks for graphing does not give us the ability to do so. So I'm going to go over to Desmos and plug this right in. So going over to Desmos, let me see where we go. Okay, so going over to Desmos, you'll see that I put the information in there. Let's take a moment and think about the problem real quick, though. This function is referring to the amount of medicine in milligrams over X hours, and we're only dealing with the time period from 0 to 6. And remember that we took 400 milligrams, or we didn't, but we're talking about 400 milligrams of medicine. So we need to get kind of a better view of what's going on. So here's what I'm going to do. Let's go back to Desmos. Let's tinker over here. We know that we only care about from like 0 to 6. So if that's the case, I'm going to go like to -1 just to give you a little bit of a view. And I'll go up to, let's say, +10. Okay, and you can see at 6 is a natural kind of, it hits the x-axis. So that's a nice barrier. So that's good. And now my y-axis has to go all the way up to like 400. So I'm going to go to 0 here, start at 0, or let's say like -5. And I'm going to go up to 400, or let's even go 450. This is just giving me a better ability to ascertain what's going on. Hopefully you guys can see my whole screen. All right, so here is what's happening with the medicine. We take the medicine, I keep acting like we're taking this medicine, but whatever. We take the medicine and the amount increases in our bloodstream. It never quite gets to 400 milligrams according to the equation, which kind of makes a certain kind of sense, right? And then it, dissipates after 6 hours. And so the question was, when is it above 300 for how many hours? What space of time within those first 4 hours is it above 300 milligrams in our bloodstream? And so what we're going to do is we're going to graph the equation y equals 300. And when we do that, we can see a clear point as to when we've reached above that 300 threshold. And so we could see it's a little bit after, I was going to say 1.5 hours, but that's not accurate. A little bit after like 1 hour and some change, not quite 1.5, that will be 1.5. And then a little bit and it'll stay up high just before up until the 3 o'clock hour, after 3 hours, not 3 o'clock, but after 3 hours of having had the medication within. Hopefully that makes sense. I hope that's pretty clear. I'm not going to belabor this problem any longer. Just wanted you to see how graphs could be used. We could also do some shading, but pretty much unnecessary. I think you guys could get the visual on this. So with that, that's all for me. I look forward to talking to you guys soon. Let me know if you have any questions about this problem or any of the other ones. And take it easy. Bye-bye.